Okay, so we want to prove by contradiction that there are infinitely many prime numbers. So if we contradict that, we're supposing that there are a finite amount of prime numbers. So we're going to suppose, I'll write it down, there are a finite number of prime numbers, and we're going to let the largest of those, so now we have a largest, so the largest prime number, as it tells us in the hint, let the largest prime number be p. Alright, so let's have a look at p factorial to start with. Remember, p factorial is p times p minus 1 times p minus 2 times all the way to 1. So p factorial is divisible by all those numbers. So all numbers from 1 to p. From 1 to p. All of those numbers. And all the prime numbers are included. So because all prime numbers are less than p in our supposition, so all prime numbers are factors. All prime numbers, I'll just put here, are factors of p dash. Alright, so any other prime, let's call it any other prime, let's call it q, must be like, say it's, in here somewhere. Then if I take p dash and divide it by the rest, let's say m, my prime is going to be equal to p dash divided by m. That means m is equal to p dash on q. So now if I consider a bigger number, let's say p dash plus 1, which is clearly going to be greater than p, let's have a look at it. So p dash plus 1, when I divide it by another prime, that little prime there, what do I get? I get p dash on q, but I also get a 1 on q. So I get an integer plus a non-integer. So, and this would be equal to, I'm going to write it backwards so you can still see everything, m on 1 plus q, which is clearly not an integer. Not an integer. So if this is not dividing nicely, what does that mean? Well, that means that p factorial plus 1 is not divisible by any prime. We've just tried to, because remember q is our any prime. So it's not divisible by any prime between 1 and p. So therefore p factorial plus 1 is a prime in itself. And we've already said that p factorial plus 1 is larger than p. So that's a bit of a contradiction. So therefore p can't be the largest prime number because we've just found a larger prime. So by contradiction there are infinitely many prime numbers.